Right, so this lecture is chapter number 9. And if you recall from the previous two chapters, we slowly get into the more advanced data or SQL language topic. And the reason that why SQL is so important, or the SQL language, it depends on how you pronounce it, is because database management system, in this case, just to clarify the concept a little bit more, one of the main improvement of the database management system, or DBMS in short, is to separate the data with the system. Um, so the main reason for separating the data and system is that the system, like Oracle database system, keep evolving all the time, right? So every couple of years, every three, usually typical in the traditional wisdom, every 3 years you will have a major release or major version update for most of the commercial available software. And so to deal with that software update, if you need to update your data, and that will be a very difficult job to do, because over time the data in most of the organization will grow, and so when your organization function or actually operate for a while, then the database can be huge. So and most of the company has a policy, or actually a schedule, to back up their data and do other things. So if you every time you want to upgrade your management system, data management system, or application, you have to change your data set. Then it will be a very um, difficult or dangerous job. I think dangerous is a better word. So because you might just very easily destroy your database. Most of us, as a modern human being, that we use computer working for university homework, once in a while you have your computer crash and you lost all your assignment. So data management become very important, and it is important to separate the data. So the when you separate the data, and you have the database management system, the management of how the system is configured and how the data is managed become quite complex. So this is a part of the database administration is coming in, and so we are going to be dealing with that particular topic in here. And the benefit of using relational database is everything we do in here is going through the SQL language, including the job of managing user. So you want to manage a user, and if you think about this, what is user management? How do you what kind of what aspect you want to manage in terms of user? From a data management perspective, the most important job of user management is what? To manage the access control of user. So you're trying to figure out what kind of user, who are, and the terminology we use here is what type of user, or what role of the user has what kind of right or privilege to access how many different database or data set. So you want to make this mapping between the user and the data they can access. In From the end user's perspective, for example, um, just look at the university environment. And you are a student, you are end user of a database, and I'm a professor, also an end user of the database. So imagine that when both of us are trying to acquire data, or retrieve data from our university enterprise system, and you and me, because we have two different roles. You are a student, I'm a professor. So when I try to go to UIS enterprise system, what the data I have right to see will be different from yours. Say, for example, I can see the entire class performance in my Canvas system, and you can only see your own grade, right? So that is what we are talking about, the privilege and the user management, and user and their privilege to the data, and some of the management functionality as well. Say, for example, as a professor, I can create exam, but you can only take exam. So those are the different privilege other than data in terms of the application that you have. the privilege to use it. So though all these jobs are under the category of database administration, again, all these jobs can be performed through SQL language. Now, don't underestimate the benefit of using SQL language to manage all this type of thing, because a SQL language by itself is more like a command line. You don't really need a graphical user interface to access the data. So that gives the system a tremendous advantage. This advantage is that you can actually access the database from different environment, right? So it becomes platform independent. You don't need to have a graphical user interface, as long as you can have some sort of a dialoguing box or something similar to the command line interface. You can now interact with the database. So that gives the administrator much better freedoms to manage the system from anywhere. All right, so let's go into the chapter 9 content by first of all introduce the concept called DBA. Now, just based on the data I have, I don't have the slide here, but basically, among all the entry-level job in the MIS field or in the technology field, DBA is still pretty high. It's not the highest paid job, but it is a relatively higher paying job compared to the other position called a system administrator. Now, system administrator is usually a person managing the network operation system environment, and that average salary is actually much lower than DBA, but the complexity actually is roughly about the same, and both roles need to have knowledge about the network architecture, but DBA, of course, need to have knowledge about database as additional requirement. So what exactly does a database administration do? And your textbook figure 9.1 give you a list of the tasks that should be or can be described as their responsibility or the task, including managing the database. It's structured, not particular independent database. Usually a person set up policy, how does a different kind of person can create what kind of database on your database system, and how do you host the database in different part of your database management system. So that is one. And you have to control concurrent processing, and that is the main topic we are dealing with today. And I'll use the example to describe what does that mean by concurrency control. And you have to manage the right and privilege and responsibility, developing security policy, and recover database and backup database. And finally, you configure your database management system so that you can enable or disable some of the feature from your DBMS system. Say, for example, one of the important feature of Oracle database system today is this web service or web server. So basically, any Oracle database management system can function as a web server. So you don't need to install another web server like Apache to run a website. So the database can by itself running as a database website. You can enable or disable that particular functionality. So that's the database management feature. You can also manage how the data files are saved. The data files are the physical location of your database, and how do you handle the data file is also part of the thing we do in there. And finally, you have this repository. Maintain the data dictionary, that so you can know how the data is stored on your database from different user and from different developer. So actually a lot of job, and many, I would say that because I have taken some of the certificate exam myself a long time ago, but 10 years ago, 15 years ago in the Oracle world, and the emphasis of Oracle DBA test is on, I think they have 3 levels back then. The first level is they will test your SQL knowledge. So if you're good with SQL, then you have your introduction to SQL sort of certificate, and then you have to take Oracle DBA that covers some of the topic you will be encountered in our next assignment, that user management, system configuration, network configuration, that sort of thing. And you have the third certificate, I believe, is on the fine tuning. So when you have a large operation, how do you make sure your database is running efficiently, right? So those are the topic covered, but not so much on the security and concurrency process inside. And this is actually covered very well from our university setting. And that's the some of the job about this DBA responsibility. On this slide, you see the additional, more detailed example of what you do as a DBA here. It is a very it's kind of like all the administration job at the end. It is a very time demanding job, right? Yeah, it's one of those jobs, just like all the system administrator. You might be called in the middle of the night, say, "Oh, your database crashed, and we need somebody to recover or reset the database." But fortunately, now that we can do this remotely, but still, that is a very time-demanding job. And for smaller company, many DBA need to face end user, so you are also work as a more like a help desk type of person, because when user need to reset their password, if you are not writing a program to help them do the thing, then you have to do this manually by yourself. That's that sort of thing, right? So and chapter 9 from the textbook's perspective focus on two things. One is concurrency control, the other is security, a little bit security topic. But again, I have to admit I'm not a expert of security. As a matter of fact, in my career of learning technology, I've been avoiding the security topic for a long time. Well, even though in almost every topic that we touch in MIS, you have to know some security. But detailed topic in terms of how do you configure Oracle system, which switch to turn on, turn off, that kind of issue in the database system is something that I didn't spend enough time in. But a general concept, of course, that we all can learn and understand very well. So I think general concept is good enough for the limited time we have in the entire semester. Besides, we have learned all these database design, and we still need to learn some of this concept. In the job environment, you probably encounter this more, and that you probably need to find a way to teach yourself or take another certificate course to cover that part of the knowledge. Yeah, one of the problem is that this type of knowledge are usually outdated very quickly, because when the system change, then your previous knowledge, the concept is still the same, but a lot of these system, how do you configure it in say Oracle 11G to 12C, it's dramatically different. Not dramatic, but at least 20-30% different from the version change. All right, so let's go to the textbook concept. Concurrency control, what does that mean? Concurrency means that something happened together, right? So the best way to understand concurrency in databases, many people are trying to use your database at the same time. What if your system cannot handle? What if there is conflict? The best example I can give it to you is that I don't know how many of you, especially guys, I know that including my son, that they have this fantasy about buying limited editions sneakers, Nikes in particular, or Adidas. So every once in a while there will be a limited edition or some say Jordan number 1 or something that will be released, Jordan 2020. So the special shoes come out. Everybody will go to Nike's website and try to bid on the shoes, right? So if you're one of those people, then you might want to think about this. How does the system decide on who get the who get to buy? How do you create a waiting list that people get into the online? Because there will be millions of people try to get to that website and try to buy this. Similar example will be like, well, if you try to buy a very hot concert ticket, Celine Dion, that was I think she's under some sort of a global tour. I think there's one in St. Louis, another one in Chicago. So when you try to buy a concert ticket, so many people when the ticket is open, go into the website, and how do you decide on who have access, and how do you rank the people going there? And so that is the topic of concurrency control, because too many people are trying to access the system, right? And this type of situation happen once a while on a retail website as well. And in I think yesterday, yes, today is November 12th. Yesterday is the equivalent of Black Friday in on Chinese market. It's called a single day shopping events. The company Alibaba, that when they evolved from a small e-commerce website to a full scale like Amazon in China kind of company, they invented this special Black Friday in China by creating this November 11th, so that if you see the calendar is 1111, so that's what they call a single days shopping events. And there will be, I think yesterday I was looking at the number. Every second there are 51 million transactions. Every second, not minutes. Every second there are 51 million transactions. So that was an amazing number. So imagine if you're selling something. Say, for example, if you're selling a limited edition of Nike shoes on China single days market, and of course you have 100 inventory. So you're saying that we have this first come first serve mechanism for you to buy the sneaker. But imagine how many people are jumping to your website and buy. And what if two-person came in at the exactly same time, same day, same hour, same minutes, same second, even same millisecond? And you're running out of inventory. Who get to decided on what are the number 100, or if the two-person came in the last millisecond and try to bid on the same shoes, right? So that will be the issue of concurrency control. Yeah, I think those examples will be good enough to understand the issue of concurrency control. And of course, concurrency issue can happen not only in that large volume. It can also happen in a long transaction. Long transaction meaning that when somebody is using that resource for a very long time, can also have that similar problem. So if somebody is using the and taking up all the resource, and you want to get into the system, it will be relatively slow. For our UIS Citrix desktop, once in a while we have this trouble, because usually that student will work on their assignment on the last day or of the due date of the assignment. So the day before the due date, the virtual desktop will be heavily used, and the system will slow down tremendously. And some of you might have experienced that when you try to log into the system, you got kicked out, or the system showed that seems to be crashing or something. That's because a lot of people are taking up this locking the resource in a way. And I'm trying to use the term that we learned here already. The resource, once a user get into the system, that particular resource is locked, allocated to that particular system. And lock is actually the mechanism we use to manage the concurrency, more or less, right? To manage the concurrency, we need to understand one of the very important concept called transaction, right? And if you are a good student and have taken the system and design class, especially taking the class from me, and I keep emphasizing that how do we decide on the right amount of work, say right amount of work for one iteration or one sprint or one agile, or even define a use case or try to define the size of a function. And a lot of time it's become a very difficult decision to make. And how large is your procedure and how many different steps in your program or business process you need to handle? How do you modularize each function? And those are the issues that related to the concept of transaction. And transaction is usually a logic unit of work. And it can be the definition can be different, depends on who you are in taking a look at the so-called logic unit. From the higher level manager, their logic unit will be larger. And say, for example, if you are a CEO for Walmart, you will not be looking at, say, your Walmart sales number every day, right? You'll probably look at the number every month at most, right? Most likely will be looking at the number every quarter, every 3 months. But if you are a store manager, then you probably need to look at the number every hours or every So the scale of the transaction will be different. So every hour will be one transaction at the store manager's level, and every quarter will be the unit for the CEO level. So in the information system world, if you are doing different job, the definition will also be different. If you're a database administrator, each one of the transaction will be more or less on how do you create one row of the data in your database. So that will be a logical transaction. But if you are a application builder or a user or company try to use this database or use this application, then the unit might be, say, every sales. So when you create a sale record, the database probably need to create multiple records. You need to create a quote. You need to create a temporary inventory check or deduct inventory record, and you have to record the money transaction, credit cards, and then finally you create a sale transaction. So in order to get into the sale transaction, you have to make 3-4 different database transaction to get there. But for the business operation, we are more interested in the final sale. The best analogy I can give it to you is that, and I know now we all go to Amazon to buy some stuff. So you browse in the Amazon catalog and you try to put something in your shopping cart. Then when you try to check out, and in Amazon there are a couple of methods of checkout. One-click checkout, or you can go to regular checkout. If you go to regular checkout, they will ask you the payment method. They will ask you the shipment information. They will ask you about the shipment method, a coupon you want to apply, that sort of thing. All the step along the way, every time you create, you select something, it's actually a database transaction. But we all know that until you click on the last button is checkout. Finally, and Amazon will issue with a receipt or the summary. If you don't click on the checkout, that transaction is what? Not complete. Right. So from the business operation level, the transaction is at the business transaction level, but at the database level is a different granularity. I think that's the term we can use to describe transaction at different level. So when we are looking at the database management, now we're looking at every transaction at the database level. So let's continue to take a look at this particular operation. Right. So this is an example of a potential problem that you might encounter when you create a multiple transaction, database transaction in a business operation environment. So the process from the top to the bottom, it seems like if you read a little bit, you see that well, do not look at the before and after, just look at before, right, to understand the business process. So the business process said, okay, we are in a company, we have two business operations going up at the same time. One is that a customer is trying to buy something, and so you create customer sales record, right? And the other is that somebody is trying to generate this sales report for individual salesperson, so you can give the salesperson commission, right? So and because the sales is continuously rolling in, and so the whole scenario here is try to tell you, okay, it might be possible that when you try to generate the salesperson's commission, new sales come in as well. So you might be getting the incorrect or missing some of the transaction to calculate the commission, right? So that's the whole process that's talking about it. So this is this is the potential situation that when you have database transactions that conflict with each other, so that result in business operation or business transaction become erroneous, right? So you have errors in the business transaction. So the so-called concurrency management is try to manage some of those things from the database perspective. And so that is, and so how do you prepare that? The way to prepare that is using some sort of error checking mechanism, consistent checking. And what they are doing here is they use this is you don't need to understand it 100%, but basically what they're trying to do there is, okay, you need to have, this is the middle part called the transaction. There that you have to complete the transaction, or change the data, change the sales data, and then after you complete these two, it means that transaction is complete. Then you can create order data, right? So that entire sequence cannot be violated. And there are two keywords here. Later you will read these two keywords in the slide from this chapter as well. One is called commit, the other is called rollback. Commit is a database or SQL keyword that you can make sure that your database transaction is correct, consistent with your business transaction before you actually record the data. Before the commitment, or not commitment, before the commit, your data will be put into a temporary storage area. Sometimes we call them dirty data or something, because dirty is not actually permanently recorded. But once you issue commit, all the record, the customer record, sales record, salesperson's record, and order record, all these three will be changed together, right? So that's that using this little, and this is a store procedure, right? Using a store procedure to make sure that your transaction is consistent, will not have concurrency problem, right? So that's the pretty much a good example actually to explain the transaction. How do you manage the transaction in the database environment? So the other important concept about concurrency is that because the computer is doing very processing all data very quickly, right? And so if you recall your introduction to computer, sort of that kind of course, the professor will tell you that there are certain features about operation system. One of the features is multitasking. The other feature might be multi-threading. I don't know if you heard about those terms, but if you heard about those terms, then you understand that the most of the computer, especially in the old day, so-called multitaskings, are not actually true multitasking, because we have only in the old hardware architecture, we have only one CPU, and one CPU handle one instruction at a time. So if you have multitask in a single CPU environment, what you are actually seeing on your computer screen is something what we call interleaving. Interleaving is that computer will switch back and forth from multiple jobs. So from the end user's perspective, it seems like multiple job is going on. Say for example, on your window you may be listen to my Zoom session. On the second screen of your computer, you're watching YouTube video, right? So the YouTube video and the Zoom session, those are two tasks. It seems like you're multitasking, But from if you're using a cheaper computer, your computer is actually processing this very quickly, switching back and forth one at a time. That's called interleaving, right? But of course, the modern CPU design that you heard the terminology called quad core or dual core. Dual core. Those dual or quad means that in one CPU they actually divide the CPU into two or four area, and this four area can parallelly process in the instruction. So that become true multitasking in modern CPU. Okay, without too much detail into the uh, computer architecture design, let's take a look at this. So concurrency is actually dealing with something called interleaving problem. So this is the example of two job being done on a database system. So user A is probably reading something, change something, and write something. So updating, reading, changing something, doing this DUI, delete, update, insert type of job here. User B is doing a similar thing but on different record. So what actually the database management system is trying to do is these jobs will be interleaving, like 1, 2, 3, 4, 5, 6 step. So three of them allocate to user A, three of them allocate to user B. It seems like they are doing the same thing from our human eye, but they are actually done with a sequence. Now the concurrency problem in database happen when this sequence has conflict, right? So this we will see in the next few slides. So this one will have a conflict when you do the interleaving. So this is in previous example. What you see here is user A and user B are updating or reading different records. So one is reading 100, the other is reading 200. So these two records, because they are independent, you won't see the conflict there. But in the figure 9-5 example, now both users are accessing the same row of data, item 100. So when user A accesses item 100, user B is access the user 100. So in step number 3 and step number 5, when both of these tasks are trying to update the item, or in this case might be an inventory item, right? So one user buy 5, the other user buy 7. It may come up with this situation, only one record is recorded, right? So that creates a conflict because both of them are accessing the database and you don't know which one is correct final data. So how do we control this potential conflict in database conflict so that will impact our business transaction conflict? And the answer is locking, or so-called resource locking. And I already used this term already before I enter the slide. So resource locking is the basic way of control. So basically it says is that if one user is using that resource, the other user cannot touch that resource. Very simple. So there will be no conflict. So once you decide on a mechanism, a queue of who has a priority to access that particular, in this case, data, then the other user will not be able to do it until you have complete your job, right? So that is the simple logic. But of course, logic is simple, but the real working situation can be very complicated because the business operation can be complicated. In one business transaction, you might have multiple database records being updated, modified, and check and read. So how do we manage it well? Then become the topic in here called concurrency control. The good news is most of the concurrency control is done by DBMS. So the Oracle, Microsoft, IBM, when they build their database management system, they have already building some of the optimized algorithm to handle this type of conflict. But so most of the time, 90% of the time, you won't encounter concurrency problem because database management system already handle this for you. That kind of handling is called the implicit lock. So the database management system will decide on who has the priority to handle a particular resource, and so when a concurrency conflict happen, the DBMS will lock that particular resource automatically. However, there are still exceptions. So when exception handling, then we call that explicit lock. It's usually issued in a store procedure that designed by the application builder or DBA. Try to make sure that you have an explicit lock to control the potential conflict. And the lock can be applied to many different levels. It can be applied to a table. So when a user using a table, then it's locked. It's one of the typical example you see this lock at files or table level is that when you use Windows, and a lot of time you probably encounter this error message when you are editing a Word document, for example. So if you're editing a Word document and you try to open out the Word document a second time, or you try to what is the situation? Copy or move this document, and the window will tell you your document is locked. Other application is using this system. Or when you try to shut down the computer, and the system will not allow you to shut down because they're telling you, or you are editing the document is not safe. And that is actually a locking mechanism. So it's basically Windows is trying to prevent you from losing your data, and because you haven't finished up your editing, that is a transaction. So you can actually lock the resource at the table level or files level, or even database level in this case. Or if you say locking the entire table will be too much, because when you try to create order, if you lock the entire order table, order can only be executed one at a time. You want to very quickly handle a lot of order, then you can change the locking at granularity at the page level or at row level. So you can have a lot of flexibility in terms of locking. It has also something called exclusive lock and the share lock. Depends on how you can have the right exclusively, or you can share. And share lock is usually used when you have this reading resource type of situation. And we'll see a little bit example when we get into the assignment exercise. You will see that you can grant the read, write, and admin different privilege. So that's pretty much actually create different kind of lock at different level. So 9.6 give you an example of using explicit lock. Explicit lock is actually telling the DBMS system, make sure in this case 100 record is locked before A can use 100 record again. So using that explicit lock, you can avoid transaction. And usually explicit lock is used in a very typical sensitive information protection. Say, for example, if you are recording a user's I don't know, maybe phone number, and that is a user profile. So whenever you try to create a user record, that information is very important. You want to lock that resource. But if you want to, record the, say, conversation of chatting in a chatting room, and the chatting, sometimes it's not that important. You lose one record or the other, and so the chatting record will not be explicit locked. And especially, and later actually they also talked about in the chapter, when you have internet connection, the so-called packet exchanging mechanism. Packet exchange, the communication of data across internet, is actually a very loose locking mechanism. So because there's always a possibility that you might be losing some of the packet, or you might be even lost the connection. So in order to make sure that, say for example, my voice communication to you is clear, the computer will not usually lock the resource. So the transaction can go more easily in that particular situation. The more lock you have, the less easier or less efficient the transaction will go through. think that is a trade-off you can sort of like imagine in the process. And more terminology about the locking, and one is called the serializability or serializable transaction. It means that the transaction can be occur simultaneously. It's called serializable. And you can also lock the resource in multiple phases, say for example, two phases of locking. And there are some explanations about how do you use the two-phase locking. And the example we saw earlier are two-phase locking at the operation level using commit and rollback. And Oracle does have commit. And actually, you have seen that we use this commit statement in our PHP example when we try to. I didn't explain the program completely, but basically what we are doing there is we use a PHP program to control the locking, and at the end of the transaction we commit, and in that way we can explicitly lock in the resource, make sure the report you generate is correct. So you got the most updated information. So that is actually an example over there in our PHP program example. Now, when locking, or actually when the concurrency problem become explicit, or when it occur, we call this kind of problem as deadlock, because sometimes when you lock resources, then if two resources are locked at the same time, then nobody can unlock the resource, and it will create something we call the deadlock situation. And usually there are two different ways of deadlocking. Deadlock in a database environment is kind of like an infinite loop. So you will be trapped into that system. You see that your computer is running and running and running, and there's no end. And in database system, most likely you are in a deadlock situation. So there are multiple ways of deadlocking, and one is that somebody can explicit deadlock. Most of the database management system has some sort of a deadlock resolving mechanism. Most commonly used deadlock resolve mechanism is something what we call timeout. Timeout is that you probably see that error message as well. Sometimes when the system does not give you a response, it will give you an error message that timeout or overtime. That it takes too much time to get a result. So when you issue a query to a database and you didn't get a result in a certain amount of time, can be 20 seconds, can be I think most of the databases give you 60 seconds, 1 minute. If 1 minute cannot be executing your query, then that will be automatically abort, and you can resolve the deadlock. Sometimes that you get into a very complicated logic situation, the deadlock may need to be done manually by the DBA. For many of us, when we see our computer deadlock, that means our program is conflicting with another program, taking up all the resource. What do? We shut down the power. We press the power button and shut down the computer. That's a manual deadlock resolving mechanism. So this is a deadlock example that one user is trying to lock the paper, the other user is trying to request the white paper, and user B is trying to lock the pencil. So one user lock the paper, the other is trying to lock the pencil. But both users need pencil or paper together to resolve or to complete transaction. So the two users end up in locking each other out, because one hold out to the pencil, the other hold out to the paper, and finally it's locked. So that's a typical locking mechanism. If you replace the paper and pencil to two different records, one is inventory record, the other is sales record, same logic apply. Right? So you have a deadlock in the inventory and sale. And because the inventory and sales are related to each other, in production operation, one of the important lesson to learn is to plan your inventory. So every time you create a sales, you have to deduct your inventory. In that way, you know how many more items you can sell. And this, so if you cannot change your inventory record, or you get the wrong inventory record, you might be selling something that you don't have. So that would be a problem. So if you selling this Jordan limited edition shoes, and you're selling two two pair, but the three customer order, then you have only two. That is a problem. That could be a disaster. You're gonna be losing a lot of money in that particular situation. And also there are different configuration you can do in DBMS. One is optimistic locking, the other is pessimistic locking, and depends on what situation you are. Pessimistic is more rigorous, more manual, and optimistic is you assume thing will go well most of the time, right? Even though there might be some concurrency problem, you can allow that happen. Then use optimistic. But if you want to make sure data quality, you have to use pessimistic locking. So it depends again on what kind of data you're handling, and if you're handling, say, health insurance, is extremely critical. You got to use pessimistic locking. But if you're handling some like again, I don't know, chatting history, then that is not that important. So don't need pessimistic locking mechanism. Some example in coding, and I will just skip the coding part and try to do that. Actually, in here we already introduced a commit and rollback mechanism already, and that using store procedure is basically when you write a store procedure, you commit at the end and the store procedure itself will create a manual explicit locking mechanism for your transaction. So that's what these example is all about. And for our learning purpose, because we're not writing the store procedure here, so we just kind of appreciate, okay, this is where it is. Good news is that for both Microsoft SQL and Oracle, the commit and the rollback mechanism are very similar. So once you read it in the pseudocode environment, you will be able to understand these locking mechanism. This one I will skip and as it has well, not skip in the lecture, but will probably recommend you to read a little bit more about what is ACID. ACID test is introduced in much more detail in most of the advanced programming courses. Right? So if you're taking a algorithm courses in computer science, you will learn more about this ACID test. But space is a very important concept in identify transaction. And so their data read, and now I'll kind of go to one last topic in our chapter 9 that is not related to the coding, and some of this are more like terminology and coding issues. I'll leave it. This is a cursor, more on the coding issue. So I want to make a 5 to 10 minutes lecture on database security instead of focusing on the store procedure and coding issues of the chapter. So let's go moving to database security. Database security very similar to other computer system security, but it has one more layer of problem you need to handle. This one more layer of problem you need to handle is particularly called the privilege handling. So it's access control. In SQL language, there is a control language or database or data control language that is common to all the database management system. Basically, we have this grant and revoke statement that we can use to grant and revoke privilege to the user. In Oracle and Microsoft, there is another statement very closely related to grant and revoke, and one that you have learned already is called the alter statement. Can do similar thing, and so when we are doing this, we have to be very careful. And grant and revoke are the ultimate tool for control the access. And the user privilege assignment and that tutorial, you will learn how to use this grant, not directly, not issue directly, but through the graphical interface SQL developer to issue this command to the user, so they can give the user different level of access, and that we will learn from doing. So yeah, so this one I'll probably come back and when we have the exercise and telling you actually you are doing some of the management and this is a management job. And now actually, and I know you what kind of diagram we are looking at here. It's an ER diagram, and one of the reason this is something that over my career teaching database management is one of the benefit of learning database management is the database management is actually a concept can be applied not only to database management. The model, the data model can be used to as a management tool for many different business transactions. In this case, the user management is handled in the process of so-called permission and role assignment. And again, going back to the concept of transaction. And if you recall that when we go back to previous chapter, and one of the pattern when we learn ER diagram is called the line item or transaction pattern. And I'm specifically telling you that you have to be very careful, put the transaction in the middle. So on this particular ER diagram, there are two transactions. One is called role, the other is called permission. These are actually role and permission assignment transaction. So you have to assign role to a user. You have to assign permission to a user. That creates transaction, right, in the user management situation. So those transactions can be managed through the visual model that we are looking at here. So simply saying that 10-second explanation about this diagram is we are trying to assign permission and role to the user so user can access the object. Right, so that's it. So that part of the thing that how do you assign role and the other important concept is role is aggregation of the permission. So you put all the permission together become the role. Right? So it's much easier to assign role than assign individual permission. Say for example you assign read and write and update. Right, read, write, and update to a developer, but you assign only read to the user. So you can say, okay, the end user has only the permission. End user is a role, has a permission only reading. Developer is also a role, has a permission of read, write, and update. And that way you can manage the permission only by assigning the developer or the end user without going to the detail of read, write, update for every person. So that's the concept of permission and role, how they are grouping. And most of the DBMS using similar concept. But actually the terminology used in DBMS are usually privilege and role. You put many privilege together to create a role. So you can assign multiple privilege using a role in that particular situation. In Oracle, the default three basic type of roles are DBA, so you can become a database administrator, or developer, or the end user, usually the three different types. And we'll take a look at the control, resource, connect, those type of role in the Oracle environment. So that's user management. I'll jump a little bit more, and finally to the level of security at the application level. So earlier when we talked about this role access control is the security at DBMS level, database level. So if you think about the architecture, database management system, application server, client, each one of this layer on your network has some security issue. So if when we are talking about say cookie management, that will be the client security. When we talk about the role and permission management, that is at the DBMS level. When we talk about the access control at the application server, it becomes the application security level. And the database application is very special because most of the database application communicate to database management server using SQL language. So in database management environment, there is a special security concern called SQL injection attack. SQL injection attack is ingenious. By the way, again, refresh your knowledge and memory about your assignment of how do you use a programming language together with SQL language. Usually you issue the SQL in the inline statement inside your programming language. This you can see that in our PHP example, we have this SQL create as a string, and the SQL will be passed to the OCI execute to execute the Oracle connection to execute a query through that PHP program or function. And so whatever the SQL insert into your program will be executed by the database server, and the result will be returned as well. So that creates the opportunity for a hacker, and this case will be somebody smart enough, because how does one system generate a customer created query? Usually by taking the user input from a text field. Say if you want to search for something, you type in something. And so if the end user is a very smart hacker, or he knows how database work, and you can probably enter here. Say for example, in this case, the intention is to say maybe search for a person called Benjamin Franklin, and this is probably the user. Well, yeah, I mean our historical figure here from the U.S. history. But you search for Benjamin Franklin, or actually the user might be Benjamin Franklin himself. But when you enter the Benjamin Franklin, you can enter Benjamin Franklin or true. And that true is the keywords here. Because when you insert this particular statement into your query, the query will see that true as one conditional statement. So that will ask you if this is true, because it's or. And true is what? True means all the record. So that will actually generate result for the entire database that you have. And this is one of the potential that so-called hacker doing to a lot of these e-commerce websites. TJ Maxx, they lost their customer information. The Target lost their customer information a few days ago. Several credit card companies lost their customer information. How can they find lost their customer information? One of the potential is that the hacker know where to inject the SQL injection attack, and that will generate the entire database, so the end user can take the data and go. That is disastrous for most of the company. So and there is actually a very simple way to prevent this. This is actually using store procedure or view, database view, to prevent the end user directly inject the SQL command in there. But that detail, how do you do that, is not a coverage that we want to cover in this case. But you have to be aware there is a method that user can inject SQL through the application to your DBMS, and then grab the data they are not supposed to be getting from their user privilege to pose as a potential threat from your database system. Right. So to summarize, what we have learned from chapter number 9 is that we learn, very importantly, concurrency and locking mechanism. How do we use lock to manage the concurrency issue? The other important topic we learn is there are security problem at every layer of your database architecture. At the application layer, at the database management system layer, at the client layer. In particular at the application layer, now you have this SQL injection sort of potential there. So you have to be very carefully. Finally, there are some other tasks your textbook will explain what the DBA's job need to be doing in day-to-day operation, and these need to be learned through reading the terminology in terms of rollback, and this is more like the similar concept you have in Windows rollback or Macintosh system rollback, and you have commit the concept and how to do all these management and backup service and that sort of thing are your job. So very broadly, we introduce DBA's role and responsibility, but emphasize on concurrency control and security issue. But in our assignment, like I mentioned, we will actually do some hands-on exercise in actually granting privilege to the user, and that I hope that can give you a reinforced learning from the DBA 101 chapter. And that's it.